Hello everyone, welcome to the EasyPower Thursday webinar series. My name is Jim Chastain. I'm the host for today's session. Looking forward to introducing our guest speakers from CBS ArcSafe. Before we do that, we'd like to make a couple of announcements. For anyone attending the webinar today, you will receive a certificate of attendance documenting the time, and most people can use that for EDU credits. And there will be a PDF copy of the slide material posted to the website along with the video recording, which will be on the EasyPower website early next week. So as our habit is to begin each session with a couple poll questions. We'd appreciate your participating. No obligation, no liability, but we would like a perspective on where people stand on the topic. So the first question is, do you have responsibility for planning for a maintenance outage? So if you would please respond accordingly. Gives our presenters an idea of how you come at the topic today and potentially the background information that you may already have. So it looks like we have close to a quorum. Let's give this another 5 seconds. And here's how people have weighed in on that particular question. So it looks like we have a pretty good distribution of folks. Second question is, have you witnessed shortcuts when coming back from a power outage? And again, I'm curious about this one because it's something that I haven't had any exposure to for years. And we're actually fortunate to have these folks join us for this presentation material. And it seems very timely, especially considering the shutdown potentials that we've had during the last year in the industry. All right, it looks like we have quorum here. Let's go ahead and share the results. Looks like we're pretty evenly split. Thank you. And then finally, are you familiar with the concepts of remote switching and racking with respect to arc flash safety? I would expect most of us have some exposure to this, and I think that's where we're going to get a lot of information during the presentation. So another 5 seconds on this. It looks like we're close to a quorum. Thank you. Here's how folks have weighed in on this one. Excellent. Again, thank you for attending today. At this time, I'd like to introduce Justin Gall and Russ Seyfried and hand the presentation over to them. Give me just a second. Justin, you have the podium.
All right, very good. Jim, you do see the presentation slide up?
Yes, looks good.
Okay, fantastic. Well, hi, nice to meet everyone, and thanks for joining us. We're excited to have you with us today. We are talking about best practices for a safe return to service following a maintenance outage. Now, this is a presentation that's based on a paper authored by Charles McClung, who has since retired, and Russell Seyfried, who's with us on the call today. So again, my name is Justin Gall, and Russ, why don't you go ahead and introduce yourself?
Yes, sir. Thank you. Thank you, Justin. Again, my name is Russ Seyfried. I'm the operations manager here for CBS ArcSafe at our West Virginia location. I'm also involved a lot in the product engineering of former owners of Martech Limited, which developed the chicken switch before we were acquired by CBS ArcSafe. My background is I've been kind of in the electrical world my entire career since I was pretty young. Did some electrician type work for many years there, and then I'm a degreed electrical engineer from the West Virginia Institute of Technology. I've got more than 30 years in the industry, typically around power distribution. I've been power distribution engineer at a couple large chemical plants over the years. Also have considerable experience in design engineering in power distribution, construction around electrical systems, that kind of thing. I think that's about it.
All right, Russ, thank you. And I'm Justin Gall. I'm our Vice President for Business Development at CBS ArcSafe. I've been in the industry about 6 years since joining Russ. at Martech back before the ArcSafe acquisition. And I focus on communications, marketing, and technical sales for us. I'm not an engineer, but I went to an engineering school for graduate school at the University of Maryland. And just, lucky to be here, but I'm glad Russ is with me on the call and can help with in-depth questions and some practical scenarios as we go through the presentation. So moving on, we're going to talk about maintenance outages and how they involve unique hazards. And really, I think we're talking about unique pressures here because we're talking about things that add to the hazard. So it's stringent time constraints that you'll have with a maintenance outage, the unanticipated tasks or repairs, returning equipment to service, and all these common real world factors, they add up to added stress. And since we're talking about hazards, I wanted to go ahead and include the hierarchy of hazard controls. Just, this was adopted in NFPA 70E in 2018, and it's just a really good way to mitigate hazards. And this is universally applicable to just about any kind of hazard. And, the best thing you can do is eliminate the hazard, and the least effective thing is PPE. And there's these steps in between. The important thing is that we think about this chart as a system. So the administrative controls need to work in collaboration with everything else. They'll set the pace for what's going to happen in terms of making sure you have the right arc flash labels in place, that there has been a study, that you're taking the proper lockout, tag out procedures, and all those are in place for shock prevention. They've got the PPE you need in place for shock and arc flash, and that you follow the steps that are required for your location. So think about that as a system and how it all works together. Russ, we were talking earlier about these unique hazards, and do you have anything else to add on this slide regarding things you've experienced in the field?
I would just say that Justin's exactly correct with this. This hierarchy of controls, I've seen that for many years, being in the chemical industry. You're looking at, the best way to, for example, if, arc flash is a big issue these days. And, one way, maybe in a situation, there's a way to accomplish the task without using electricity. Probably not possible, but those kind of things could be considered. Maybe you just eliminate the use of electricity and then you no longer have a arc flash hazard. So they've taught us over the years how to think through processes that way and realize that that upside down triangle you're looking at there, at the bottom of that triangle, it's so small because that is actually and it says here down the side, that's the least effective. You can require PPE. PPE is not guaranteed to work. Maybe they don't have it on right. Maybe the person decided not to put it on. So it's kind of the least effective way. At the top of that triangle, the further you get towards the top, it's the most effective. I mean, if you've eliminated the use of electricity, then there's not going to be an arc flash hazard, and no one's going to get hurt from an arc flash. So anyhow, it's just this hierarchy of controls is a good way to think things through anytime you're dealing with any kind of hazard. Yeah, no, I love this hierarchy of controls. I think it's so applicable universally. I didn't think about you worked in the chemical industry, so you were dealing with not just electrical hazards, but also chemical hazards and probably other forms of it. So yeah, thank you for that. So today we're talking about the electrical system, though, and how maintaining that is certainly a must. And so we're looking at the continuity of operations, how that prevents loss in all of its forms, and people protection, including shock and arc flash. Now, one thing I like to point out is just our experience at CBS ArcSafe with things around like incident energy, for example. Incident energy is directly proportional to speed or time and the available current, right? So if the equipment isn't maintained and it takes longer for a breaker, for example, to perform its tripping operation when the trip button is pushed, well, that, if because of a lack of lubrication, or maybe the lubricants back in the breaker have turned hard because they weren't maintained, or the breaker hasn't been exercised, then there's going to be an increase in that in the opening of that circuit, in that circuit breaker, and the tripping function. So as that time increases, directly proportional is the increase in your incident energy. So even this arc flash studies, if the breakers and the equipment isn't maintained, could be incorrect, I guess. Russ, what do you think about that? Anything to add in that vein of thought? Yes, and you're exactly correct with that. So, when you're doing an arc flash study, the amount of arc flash energy that comes out of a possible arc flash is like you said, depending on how much available fault current you have and how long that fault is lasting. And that depends on the upstream protective device. There's a breaker somewhere or a fuse or something, hopefully upstream, that's going to say, hey, there's a problem down here. I need to clear this fault. I need to open up. And that time that it takes to do that is based on some protective relay settings that you might have and how long it actually takes that breaker to operate. And every breaker is different depending on the size of it. People think that a breaker opens, it just kind of opens instantly, but the reality is there's moving contacts, there's moving parts. All those parts have mass to them. And from a mechanical standpoint, even whenever the breaker's got the signal to open, it takes time to get that mass moving and get those contacts open and get the arc out. And that all may happen, in a cycle, which would be 16 milliseconds. And if the breaker's not operating up to the way it was designed to be, if it's dirty, hadn't been operated in a while, even a small amount of it, okay, now it takes 20 milliseconds instead of 16. That would make a huge difference on your arc flash calculation.
Sure.
Result.
So, having worked in a plant environment, Russ, I'm sure you've seen this too, where, during an outage, there's all these competing wants among all the management and even the site level workers involved. You've been in these shoes before in the plant setting, and you've been the electrical distribution engineer. You were in those shoes. So walk us through what those competing wants are in that scenario, and just a little bit on your experience and how that impacts things.
Right. So the environments that I'm mostly talking about here are larger environments, where you're a power distribution engineer, maybe the electrical system is feeding more than one operating department. So, you're trying to schedule a shutdown on your equipment so you can do some maintenance on it, but you have to get buy-in from multiple people and multiple processes because you're going to quite likely have them shut down during this time period. So, so there's a business side of it where, they have a product, whatever they're making. And in the case of me, it was mostly chemicals, but it could be anything, a product that they're making that they need to get out the door. They got customer demand they have to meet, contracts they have to fulfill. So there's a lot of pressure to get this done fast and back to normal. Of course, as the engineer, power distribution engineer, you have a certain amount of time to work that they may agree to give you, and you want to get as much done during that time, which leads you to, there's a tendency there to hurry, and that can lead to cutting some corners sometimes. You got to be careful you don't allow that to happen to you. Of course, the people doing the work, they want to meet the schedule and get it done on time. And again, there's pressure there to hurry, and there's this pressure to hurry from any avenue that you can imagine.
One thing I found interesting was the discussion about, I think it's the third point down here, is the justified reason for the outage, and the maintenance crew might need to justify, I guess, the expense of having that outage, but also they don't want to find some big expensive surprise there either, right?
Correct. That's right. Yeah. There's always a huge justification on that. Management's going to want to know, why do you need to do this, and you're correct. What's it going to cost, and what might you find? You ask for 4 days and you get in there and you find some major problem. Are you going to be prepared to deal with that? Maybe you don't. Something that you didn't count on finding, and it's going to take you a week to get the parts to fix it. How do you deal with that?
Yeah, that's a great point. So all these real world pressures, they produce a higher risk situation, right? So especially when it comes time to getting re-energized. Let's talk a little bit about the categories of risk creation that were outlined in the paper that you authored here. I see that there's equipment deficiencies, there's the risk of tools left behind. This is all before re-energizing, right? And then there's a tyranny of the urgent. And I feel like when I look at this, there's a big glaring fourth category, and maybe that's a lack of proper planning, because there's a lot of places, and even when we're out in the field, sometimes we come across sites that maybe haven't really thought through their electrical planning much. and all this kind of breaks down to safe equipment, safe work practices, and safe environment. And I guess that tyranny of the urgent really puts pressure on all those sectors.
It does. It really does. And planning is so important. Having a good plan. And all I can say is you can never imagine or think through everything that might go wrong or might happen to you. And even things like usually in these types of outages, you've probably done some things to get maybe some temporary power to some units or some part of your customer's equipment so they can keep something up and running, or maybe you've done switching so that you can feed power from a backup source somehow. And have you really thought through of like, well, gee, when we're in the middle of this outage, what happens if that backup source fails and now we have no more backups to feed them? Or what if that generator fails? Maybe we need to have 2 generators here ready to go. You need to make sure. It
sounds like a best practice is really trying to think through the domino effect of any one thing that could go wrong, and that sounds like a lot of planning to me.
Right. It's so easy to say, well, we got a backup feed for that substation. We'll just put it on the backup feed. Well, you do that, and now that substation doesn't have any more backups anymore, possibly, and it'll just be Murphy's Law that something will happen to it while you're in that 4-day outage.
So the first category there was equipment deficiencies, and we're talking about careless acts such as leaving wires disconnected. That never happens, does it? Incorrect maintenance, and such as replacing a part with a defective or maybe an incorrect part. You've been in the field. Have you seen other examples here? Are there more, or an example of incorrect maintenance?
Oh, yeah. I mean, of course, nowadays, there's a lot more pressure to make sure people are trained right and know what they're doing. But, I think the reality is a lot of these outages you get into, I mean, you might be working on, Schneider equipment, and you've brought Schneider in to do the maintenance on your breakers. And you'd like to believe that those people that Schneider brought in are fully qualified and understand the actual breaker that they're working on and how it needs to be maintained. I think the reality of that is that's probably not often the case, because on a big shutdown like that, Schneider may not have the number of people that they need to truly support you. So they've gone out and hired maybe contractors to help them that aren't necessarily, a Schneider person that's actually worked on these types of breakers for their whole career. That definitely holds true if you're using your own people to do the work. Most of your plants, your own maintenance people kind of have to be a little bit of jack of all trades, because they're working on a little bit of everything. And although they may know how a breaker works and they generally understand it, but do they really know how important it is to use a certain type of grease on an XYZ breaker that you have? So and that all plays into those last 2 bullet items you have there. And even replacing a part with a defective part, I mean, do we find you're in there and you find something that's defective and you say, well, we got another one of those over in the warehouse. Of course, the warehouse might have a bunch of new stuff, but it's also got that last trip coil that was bad on you that you took out of a breaker 2 years ago that ended up back on the shelf. So are you putting another bad part back in there? How well are you controlling that?
We're talking about re-energizing in this presentation, and what comes to mind as we talk about equipment deficiencies is how many of our customers reach out to us for remote switching or racking when they're commissioning brand new switch gear. It seems like first time something's being energized is maybe even a risk point to consider.
Oh, it definitely is. I think the stats will show you that your first year of operation of brand new equipment is when it's really most likely to have a problem, because during construction of that equipment and installation of it, there's just so many opportunities for mistakes to be made. And whether the manufacturer made a mistake or your construction installation folks made a mistake. And I think there's some stats out there that show that within the first year of something new being put in if it's going to fail, you're going to find a lot of failures in that first year. Yeah.
And what's an example of something that goes wrong when a wire is left disconnected?
Well, obviously, if it's disconnected in such a way that it disables the function of, say, a protective relay, you could easily have a breaker in service that will never ever trip on a fault because there's a wire that's been left off.
Yeah.
You could leave a wire disconnected to the point to where it dangles in and maybe gets into the bus somewhere or into the higher voltage part of the breaker, and that could cause an arc flash at any time. Maybe when you rack the breaker and it causes it. Yeah, there's lots of hazards of leaving wires disconnected, or even similar to that is not just leaving it disconnected, but maybe hooking it back up the wrong way after you've had it unhooked.
Or maybe loose.
Right.
Yeah. So let's move on here. We got the second bullet point was tools and items left behind. Tools can be left behind in an area that could create a fault. Inspection should always happen to ensure tools and other items have been removed. And we have a point in here that it's not just good practice, but it is also the law according to OSHA. Let's take a look at that. It says a qualified person shall conduct tests and visual inspections as necessary to verify that all tools, electrical jumpers, shorts, grounds, and other such devices have been removed so that the circuits and equipment can be safely energized.
Right. So that's really a big thing. You wouldn't think it would be as much, but leaving tools in there. One example is grounding cables. And my goodness, what facility doesn't have a story about some ground cables got left on during an outage of some sort? And you go to re-energize and you're energizing right into a fault. One of the companies I worked for, we had a policy there, and this was the best policy that I've seen anywhere that I've ever been involved in, is anytime you put a ground on somewhere, you've got that breaker locked out on some sort of lotto system. And anytime you add a ground anywhere, those ground cables get a lock put on the lock box, just like a person would. They essentially become a person. And you hang a tag on the ground cables, you take the key for the lock that belongs to the ground cables, and you tie wrap it to the ground cables, and you actually hang a lock on that breaker or system of breakers. So there's no way that can be re-energized without getting that key off those ground cables and hopefully reminding you that you've got them on there.
Mm-hmm.
So that's an example of leaving, I guess, a tool or jumpers, there you go, or grounds on. But yeah, you've got to be so careful that you haven't left a little piece of wire, especially if you're doing a lot of testing or something, and you have to make little jumpers out of number 12 wire or something on your breaker to do some mega testing or high pot testing with, and you leave a piece lay inside the breaker, you're going to have problems, big problems.
So tyranny of the urgent, that was the third point. And that's when we're rushing to complete a maintenance task. Things can happen when you're rushing. So maybe you evaluated the test results too quickly and didn't pay enough attention. You could forego some maintenance activities to meet a time deadline. There might be the temptation for a crew to cut corners to meet that time deadline. And then also, we see it all the time when we're rushed in our personal lives, and in many facets of life, we can forget basic things and safety interventions. I'm a mountain biker, Russ, and when I went recently mountain biking, I took off from the truck and I started down a hill, and I got probably a mile into the woods before I realized that I did not put my helmet on. I was in a hurry to get out there.
Yeah.
Oh, and I felt like an idiot. I had to turn around and go back. And, I apologize to the folks I was with, but, we can't forget basic safety interventions. And it's just so easy when you're in a rush or a hurry.
It is. And I don't know that I can think of a single outage that I've ever been involved in that there wasn't a tyranny of the urgent involved. There's always a deadline, they're wanting to back up. And sometimes all the planning in the world doesn't work because you plan for a 4-day outage, and then 2 days before the process area says, we didn't realize this was going to happen. So, can you do that in 2 days now? And, you're at a point to where that temptation to cut corners, you almost have no choice but to do that. You got to start looking and saying, well, gee, these are the maintenance items I'm going to get done, and these are the ones I'm not going to get done. And
sure. We're going to come back to this, but what you just said triggered a thought, and that was about communication and how important that is. with the other groups involved. And, one of the questions I had for you is, how does this affect other groups when this urgency is happening?
Well, you mean other groups, like maybe?
Sure, within the plant.
Yeah, within the plant. Well, it obviously, I guess from one standpoint is, if you've asked for a 4-day shutdown and you're not done after 4 days, that's not good. So,
right.
You gotta be well planned. You need to be asking for the right amount of time, when you go into that. But of course, if you don't meet your schedule, that could affect the production side, where customers' needs aren't being met, and that kind of thing, which none of that is good, obviously.
Yeah, so uncertainties are created in times of urgency. Again, we're under a time pressure with these maintenance outages, so we have to ask ourselves key questions about, is the information that I need gathered, or could it be misinterpreted? Is the installation resistance too low to energize, or can the equipment that we have out of service, can it safely be returned to service?
Right. So you're always going to have that also. You may have some standards, maybe some corporate standards. You may have your own standards that say that, this cable ought to have at least, score a certain number on the high pot test or on the Megger test. And, maybe that number is 5 megs, and you get a cable and you test it and it reads just under 5 megs, so you have to decide, what are you going to do about that? And there's going to be tremendous pressure to say, well, it's close enough to 5 so that you can proceed. But, you're going to be faced with those kind of pressures, and you need to have, a good plan going into it of what you might do. What if you do get a number like that, to where it's just really close? Are you going to say, by golly, I said it was going to be 5 megs, so that's what we're going with, and we need to pull a new cable in there, and that's going to take an extra 24 hours. Are we prepared for that?
Mm-hmm.
Again, that's just the uncertainties that's going to come during that outage, and it's going to affect the urgency of it.
So let's talk about some mitigations. The return to service plan. Well, first, I think one of the key mitigations is to make sure you have a comprehensive electrical safety program already in place, right? Then we move on to the return to service plan, and we want that to be well written and conceived. We need a qualified person performing the planning. We need a detailed sequence of operations for energizing the system. Responsibilities of those involved should be clearly assigned. We need to review that with the team. We need to make sure the team verifies that they understand that plan.
Correct. So there's nothing's going to beat a well-written plan for returning it to service. You need to have in my opinion, any step that you can imagine that you're going to be doing, you need to put in that plan, and it should describe in there, you're going to reinsert the DC fuses on the breaker 12F or whatever that breaker number is, and there ought to be a place where someone initials off that it's been done. And you just, you want a plan where it covers every step along the way of what you need to be doing to bring it back into service. And additionally, you ought to have a similar plan, very similar written plan on what did you do to get it out of service, to get it locked out and be safely locked out. And like we say here, the responsibility of those involved should be clearly assigned. I think it's really important to review that with your team that's going to be working on the equipment. The ability to do that, if you have an outage that's going to involve, 50 maintenance type people, sometimes it's harder to do that as a team. Maybe you're going to be meeting with their leadership, but if you have a smaller team of 5 or 6 people, I always thought it was very important, that in the days before, that you sit down and go over that plan with them. Those are going to be the guys that's going to have their hands stuck in there working on this equipment. And if you don't have it properly locked out and started back up, they're going to be the ones that's going to get hurt. As I've mentioned to Justin before, the other thing to keep in mind is I always like reviewing those plans with the team. But I was also conscious to the fact that I don't know how well they listened to me when we were going over it. had a pretty good reputation with putting together good plans, and it's easy for those guys to just say, oh, he's got it covered, you know, everything will be all right. And it really makes me nervous when I see that they act that way, because I really want them to critique any plan that I put together.
So let's talk about mitigations a little bit more. Contingency planning, procurement of repair and placement components, supplemental manpower. You know, are we having to supply temporary power in certain areas because of this outage? Could there be inclement weather come in? And you know, another consideration is, do we have the availability of temporary equipment that we might need during the outage? And these are things that need to be thought through from a contingency perspective.
Correct. Yep, all those are good things. That's all part of your planning. And the more that you can be prepared for, the less tyranny of the urgency situations you're going to have come up.
So a plan for the plan.
Yeah. So when something goes wrong, you're going to say, we got a plan for that already.
Sure. Some more safety related work practices. You know, coming back to communication that we mentioned earlier, we want to communicate hazards. There's such as incident energy that must be understood and quantified by all involved, including contractors. So when you as a host employer have responsibility for the contractors and the employees on site. Also plan and specify the PPE required. Plan that should also specify other mitigations, such as your administrative controls, the use of energy reduction devices like your maintenance switches, and also identify areas where remote racking and switching are utilized. And I think training is so highly important of all personnel, being up to date on your NFPA 70E and the CSA Z462 there in Canada. You know, think about the overall electrical safety program training and lockout tagout. You know, we'll make sure that we are compliant with shock and arc flash hazards and training around that. Inspect the equipment, how to inspect it, and also how to use equipment. You know, when I think about use of equipment, we sometimes see customers that maybe we sold a remote racking device to a few years ago, and maybe the people we originally trained as the OEM have moved on or retired, and then someone else comes in to take over that position. And it's not too uncommon to run into the situation where that person that took over the responsibility has not had time to really learn how to use the equipment, and that puts them at risk. So, you know, do we know that they're using the equipment according to how it should be used? Do they have a risk of over torquing a breaker, or maybe even not getting far enough away from the switchgear while they're using it? You know, other training things to consider is maybe egress and you know, getting out of a location, or first aid and CPR. Just make sure all that training is up to date. And NFPA 70E recommends that every 3 years that workers are trained on electrical safety work practices, as well as the tools involved with those. And then, even if it's done less frequently than one time per year, those employees should have training done on an annual basis. Then there's other mitigations. Russ, I'm going to let you talk about this a little bit. Talk to us about closed transitioning switching and how to avoid and minimize that.
Okay, and that comes down to mostly in main bus situations, or maybe you have a substation that you can feed from two different sources, and you know, whenever you close that tiebreaker and those two systems are tied, the two sources are tied together, your equipment may or may not be rated for the amount of fault current that's available there. There was a time not too long ago when that was standard engineering practice when you design a substation, as you said, well, anytime that tie is going to be closed and the two systems are tied together, we know those breakers are underrated, but it's going to be for such a short amount of time, that's okay. And nowadays you're finding companies where they're more likely to say, no, we got to buy higher rated equipment and make sure that doesn't happen. But you need to keep that in mind. I mean, even if you have rated equipment, you got to realize when that tiebreaker is closed or the two systems are tied together, you've definitely got a lot more fault current available, which means your arc flash hazard goes way up. But you know, at the end of the day, you just really want to. You're likely not going to be able to avoid doing it, but you could definitely minimize the amount of time that the two are closed together. anybody that's familiar with our CS01 chicken switch, that was Charlie McClung's idea when he designed that, and he was working in a situation just like we're describing right here, where he needed to close a tie breaker. He had underrated equipment and didn't want anybody standing in front of it, and he was looking for a tool that would allow him to do that and could not find one, and that's what gave him the idea to develop our CS01 chicken switch that he could put on with over the pistol grip switch with some magnets and get out of the way so that no one at any point in time would be standing near that switch gear during that switching activity. And again, the inspecting for foreign objects, there's some requirements there that OSHA requires you to, make sure that you've inspected for all that, before you re-energize. See, a qualified person shall conduct tests and visual inspections as necessary to verify all tools, electrical jumpers, shorts, grounds, and other such devices have been removed. So all those words, when it says qualified person, what makes somebody qualified? That could be a point of argument, probably. Employees exposed to the hazards associated with re-energizing a circuit or equipment shall be warned to stay clear of the circuits and equipment. So obviously, you want to be as far away from them as you can be whenever you re-energize.
So that brings me to a shameless product plug here, Russ. So just about our CBS ArcSafe and what we do, we design equipment that gets you away from electrical switchgear during potentially hazardous tasks such as remote switching or switching the electrical status of the breaker between open and close, and also racking the breaker or extracting and installing breakers. So we give you the tools to do that with over 700 different designs for energizing and re-energizing. So both switching and racking, this is great for situations where you have high arcing fault current situations. We have universal and application specific designs. And if you look at the photos here, you'll see a single use racking device for a Magnum DS breaker there on the top left side. And then right next to it is a charge trip close actuator for a Magnum DS breaker. It pushes the trip and close buttons. Down in the lower left corner is a switching device for pad mounted transformers. So that device is allowing the technician to stand up to 300 feet away outside of an arc flash hazard boundary per se and operate that device. And in the lower right corner is a trip and close actuator, again for those Magnum DS circuit breakers. But basically any kind of switchgear in North America, we have a design for, and if we do not have it, we will work on it. So that's what we do at CBS ArcSafe, and just want to let everyone know about that. And get back to our presentation here real quick. What about re-energizing after an emergency or an unplanned outage? We've talked a lot about maintenance outages, which are usually planned and thought through, still in a tight timeline. But what happens when we have an emergency or an unplanned outage, Russ?
Well, that brings a whole other set of problems to the game. And what we're thinking of right here, what I'm thinking of is, what happens if you live in an area where you have hurricanes and, you just had 6 feet of water in your facility. So that means all your electrical equipment was under water, under salt water, no less. What is your plan to get that re-energized? You're dealing with a situation that may or may not be something you're used to. When you go in and do normal maintenance on a substation, you're not normally planning on how do I clean all this saltwater residue off my equipment when I'm in here. So if you live in an area like that, you kind of need to think that through a little bit, but you can, without me saying much, you can just imagine all of the hazards that can bring to the table when you're trying to re-energize something like that. And again, you're going to be under the tyranny of urgent again. Folks are wanting their power back on. Not much can happen without electricity to get a plant back up and running. And they're going to want that electricity turned on, one of the first things that gets power back on. So you need to be thinking about, how you would deal with that situation. And that could trickle down to other, tornadoes or whatever, maybe some wind damage or wind through stuff into your switchgear. Maybe it's outdoor switchgear. And you got all this physical damage to the switchgear that isn't something you're normally dealing with in an outage.
Absolutely. So in summary today, we're talking about returning equipment to service is potentially hazardous. The probability of an incident increases with equipment deficiencies, human error, time pressure, poor judgment, and as we said earlier, a lack of planning ahead of time and having your electrical safety plan in place. The key to a best practice for a safe return is understanding the risks involved and having a good mitigation plan to reduce or eliminate those risks. And with that, Jim, Russ, you have anything else you want to add, sir?
No, I think that's all. Appreciate everybody's time hanging with us today.
Okay, well, we'll open it up to questions. And we're watching for those now if anyone has any.
Appreciate the presentation today, guys. Those were very thoughtful insight. And reflecting back on my experiences, there are times I wish I'd thought ahead before I jumped into something that I wasn't prepared for. All right, I think anything else, your contact information is on the screen, and people can ask for follow-up with the survey. So thanks
Very
again.
good.
Look forward to joining you folks down the road.
Yes, sir.
Right.
Yeah, if anybody has any questions later, feel free to email me at that email address or call me at that number.
All right, have a good day.
All right.
All right, you too. Thanks for joining us, everyone.